2250, and what is the units? Just pounds? Foot pounds, right? Foot pounds. So for English units, we always say the distance first. Kenzie? On to the next one. F2 is?
40 pounds times 25.
Great. And is it negative and positive? Fingers go in the direction of force, palm goes towards O.
Negative.
Negative. Okay, Ethan, how about the next one? So we're trying to find the moment about point O due to F3. So F3 goes up along, along the y-axis, and this is the point I'm trying to find the moment about. What is the perpendicular distance between those two?
50.
How did you get that?
Isn't it the distance across the
Oh,
y-axis?
did you use this 50 right here?
Yeah.
Okay, so the force is going in this direction, and we're trying to find the perpendicular distance between this
Oh,
force
it's
and
not
the point.
50, it's
this.
what's 50, what's that, sine? No, cosine, 30 degrees, right?
Okay, good, but is it just 50? Because we're looking at F3 goes along this line, and we're trying to find it about this point.
Oh, no, it's not 50, it's 100. Okay.
So 20 times 100 times the cosine of 30 degrees. So let me go back for a minute. On this problem, everybody look up here. On this problem, it was easy to see what the perpendicular distance was. Here, it was difficult to calculate the perpendicular distance. We broke the force into components. Here, the perpendicular distance isn't given, but we can calculate it, and it's not that complicated, right? If we have this 100 distance here, and we know this is 30 degrees, this is 30 degrees, here's my perpendicular distance. So it's 100 times the cosine of 30. Dan, you had a question?
No, I was doing the right hand rule.
Okay, so we're doing that. So fingers go in the direction of the force. Ethan, is it positive or negative?
Negative.
Fingers go in the direction of force. Palm goes towards O. It's a negative value. And what does it come out to be? 1732 foot-pounds. So if this problem said, what is the moment, and that's really what I'm asking here, what is the moment about point O due to all three of these forces? Everybody? What is the moment about point O due to all three of these forces? What should I do? Daniel, G? Oh no, Daniel. Add them all up. So we have negative 2250, negative 1000, negative 1730. It comes out to be negative 4982 foot-pounds. Julian.
Since point O is canted right there, we're not going to take that force 3 and break it up into two components?
No, because the only reason I broke this up is because I was having difficulty doing the geometry to find this perpendicular distance. But in this problem, the perpendicular distance between this force and the point is here, and I have no problem doing trig.
Yeah.
So it's just 100 times the cosine of 30. So I only break it up when it's difficult for me to find the geometry, to find a perpendicular distance. So we had two where we could see the perpendicular distance right away. Here it was difficult, so we broke the force up into components. Here I was able to find the geometry. One more problem. I want you to find the moment about point O due to F1 and F2. So I want you to find the moment about point O, which is the base here of this bracket, due to F1 and F2. Before you start the number crunching, look at the problem and see if you can do it in an easier way. You're given two forces, but they're both acting at the same point. So what can we do to make it a little bit easier? Yeah, get it to be one force first.
So both forces at the same time, not force of one and force of two.
That's right, just do it all together, because what I wanna know is I wanna know the moment due to on point O due to those forces. And they're both concurrent, they're both acting at the same point. So did you find the resultant first? Did you find the resultant first? So what did you get? What is Fx equal to? What is the x component of force equal to?
Root two.
Say it again?
Root two. Square root of two. Do I do that wrong?
It couldn't be, because take a look at this. You have 5 and 3, and we don't have roots, right? We always find regular numbers.
Oh.
Right, that's like math, because they don't really care what the number is. Root 2 is fine. They have a real. Gracie, what'd you get?
Is the answer 5.65 meters?
5.65 kilonewtons. Did somebody else get that?
Oh.
No,
Yeah.
I'm asking like the moment.
Oh, that was asked? No, I'm asking you what the, okay, what was your question?
Like the moment, like, I'm not sure if you already have the answer, but like in the moment is.
No, I'm not there yet.
Okay.
So first I want to know what the x component of the force is.
I got it 5.65.
Oh. 5.65, and somebody else
You're
get,
combining the x of each one.
yeah.
Mm-hmm.
What did you get for the y?
That's probably
1.41.
Say it again?
1.41.
1.41, and was it up? Is it a positive y?
No.
Take a look physically, should it go up? Or, you guys look
Yeah,
here.
yeah, it should.
They're both at 45 degrees, this one's 5 going up, this is 3 going down, it's gotta go up, right? Okay, so now, find the moment about point O. So the moment about point O is gonna be equal to 1.41, and where are we? Here, David. 1.41 times, what's the perpendicular distance between the 1.41 and point O?
300 millimeters.
300, and do you want to use 300, or do you guys like to say 0.3 meters? We're going to do 0.3. And is that positive or negative? Fingers go in the direction of the force, palm goes towards the point, positive. And then Gabby, 5.65 times, what's the perpendicular distance between 5.65 and point O? Right, I'm gonna put 0.5. And is that positive or negative? Fingers go in the direction of the force, palm goes down, negative. And what does it come out to be? I got 23.8, no, 2.38. What is this? This is a kilonewton meter. What did you get? Did anybody calculate it yet? Mark, Malcolm?
Shouldn't it be in Newton meters because it's kilonewtons, but times millimeters?
It should be kilonewton millimeters if I use the 300 and the 500.
Oh.
But notice what I did is I multiplied it by 0.3 and 0.5 instead.
Oh, I see.
What value did you get?
Not that.
Well, what's that, 2.38? And was it positive or negative? Negative? Okay, look at it physically. Once you get values, just like we do the positive and negative visual check in forces, we can do it with moments too. We're looking at finding the moment about 0.0, and we have this force pulling on it like this, and this force pulling it on this. Don't you expect it to be going this way? These forces are cantilevered out. This is a cantilever out. It's giving you a negative moment. Did we have to find the resultant? I didn't have to. I could have just found the y component of F1, the x component of x1. I could have found the x component of F2 and the y component of F2. And I could just multiply each one of these forces by the perpendicular distance. But I thought it might save time if I found the resultant and did it. Basically, we're taking the value of the force, multiplying it by the perpendicular distance, and then using the right-hand rule. Okay, let's stand up and stretch.
The same numbers.
Okay, questions on finding moments about a point due to a two-dimensional force? Okay, I owe you 5 minutes because I kept you over once, so we can end right now. Homework.